On page 47 in the workbook, our final type of quadrilateral is the first one we've seen that is not a parallelogram. So we'll start fresh, and all we really know about it, since it's a quadrilateral, is a trapezoid has 4 sides. We're back to just kind of generic quadrilateral. However, a trapezoid is a quadrilateral that has exactly 1 pair of parallel sides. So 1 and only 1. So a parallelogram is not a trapezoid. The 2 sides that run parallel are called the bases of the trapezoid, and then the non-parallel sides are the legs. Every trapezoid has 4 base angles, and they're formed by the leg and the base. So angle 1, angle 2, this is 1 pair of base angles, and angles 3 and 4, that's another pair of base angles. If the legs happen to be congruent to one another, like in this trapezoid, so this is the type of trapezoid people generally draw. If the legs are congruent, then it's considered an isosceles triangle. Just like an isosceles triangle, it's going to have 2 congruent sides. In an isosceles trapezoid, those pairs of base angles that we mentioned are always going to have the same measure. So this pair are equal, and these 2 are equal as well. Likewise, if the trapezoid has 1 pair of congruent angles, then you know it's isosceles. Then these 2 sides will be congruent, and therefore the remaining pair of base angles will be congruent. And it's isosceles if and only if its diagonals are congruent to each other. So remember, if and only if basically means that the converse is going to be true as well. So if you have a quadrilateral and a trapezoid, and that trapezoid has congruent diagonals, then it's definitely isosceles. If it's isosceles, then it definitely has congruent diagonals. It works forward and backward. Both are true. So let's look at some problems using these properties. The body of a guitar shown is a trapezoidal prism. So we know that a guitar is 3-dimensional, but just looking at the face, this is an isosceles trapezoid. Well, these are the 2 sides that run parallel to one another. AB and DC are bases, and AD and CB are congruent sides. Prove that X is 11. So we've got a proof here. And we've used a little bit of algebra, it looks like, in our proof. So how do we know it's an isosceles trapezoid? That was given. So how do I know that AD and CD are congruent? That's the definition of an isosceles trapezoid. It has congruent, non-parallel sides. And anything that's congruent is going to have equal lengths, because that's what it means to be congruent. So that's definition of congruence. And now we're going to be doing some substituting. So we've replaced AD with the 4x plus 5, and we replaced the BC with the 5x minus 6. That's substitution. And now they'll start solving this. And the first thing they did was subtract the 4x from both sides to produce this. So that was the subtraction property of equality. And then they're going to add 6 to both sides to end up with 11 equals x. So that's the addition property of equality. And then remember, they took this equation and they flipped it around. So this is saying if 11 equals x, then x equals 11. That's the symmetric property that says either way you look at it, it's the same. So rather than transitive, which we usually use, this one was symmetric. All right, so let's find the measure of angle A if angle C is 72 in this particular guitar. So if C is 72 degrees, it is a pair of base angles C and D are a pair of base angles. It forms a pair with D. So this is also 72. The non-base angles, these two angles are going to be supplementary to one another. Just occurred to me that that actually wasn't one of the theorems listed in this particular book. But we know that in any quadrilateral, the angles add up to 360. And if you add 72 and 72, that's 144. If we subtract that from 360, that leaves us 216. And then if we cut that in half, because these two base angles are also congruent, each one of these will be 108 and 108. But it turns out that the angles that run between the bases in an isosceles trapezoid are always supplementary to one another, and these do indeed add up to 180. At any rate, the measure of angle A was 108 degrees. All right, let's find the perimeter of that guitar. So the four sides were all expressions. And so what we're going to need to do that is we need to use the fact that x was equal to 11. We solved for that in the proof. So if we add all four sides together, each of these things will need to be replaced with 11 in a moment. Let's go ahead and group up our like terms though. 3x, 5x, 3x, and 4x is 15x, combining the x's, minus 2, minus 6, plus 9, plus 5, that's a positive 6. So it'll be 15 times the 11 from up above. 15 times 11 is 165 plus 6, which is going to give us 171. The perimeter is 171 centimeters. All right, I'm going to save these coordinate geometry problems for class. We'll do these together in class now that you've seen the properties of trapezoids, specifically isosceles trapezoids.